In this module, we will compare the electrical systems of the A330 and A320. We will show you the similarities and will highlight the differences. Like the A330, the A320 has two engine-driven generators with two integrated drive generators, IDGs, and an APU generator. Any one of them can supply the entire aircraft electrical network. Each generator supplies alternating current, AC, to its respective AC bus. Then the alternating current is converted into direct current, DC, by transformer rectifiers, TR1 and TR2. The A320 electrical system also includes two essential buses. Like the A330, the AC essential bus is usually fed by AC bus 1. But on the A320, the DC essential bus is normally supplied by the TR1 via DC bus 1 instead of essential TR on the A330. Like the A330, DC bus 1 feeds the DC BAT bus. The DC BAT bus can charge the batteries or receives power from them. On the ground, the A320 can be supplied by only one external power source instead of one or two on the A330. As a backup, there is an emergency electrical generator, Emer driven hydraulically. On the A320, the Emer is driven by the RAT via the blue hydraulic system instead of the green one on the A330. Note, if the RAT is required on the A320, the Emer is cut off at landing gear extension instead of slats extension on the A330. A static inverter allows a part of the AC electrical network to be supplied from the battery 1 only, BAT1, instead of the main batteries BAT1 and BAT2 on the A330. To complete the schematic, in the case of severe electrical failure, there is also an essential transformer rectifier, essential TR. The essential TR can supply the DC essential bus from the Emer or any AC bus. Note, on the A330, the essential TR normally supplies the DC essential bus from AC bus 1. On the A320, ECMU does not exist. Note, on the A330, ECMU controls the following: AC-DC contactors, except TR contactors, galley shedding, automatic, no brake power transfer, NBPT function. Now, let's briefly review the A320 electrical components and see how they are displayed on to the pilot in comparison with the A330 by highlighting the differences again. There is only one Elec ECAM page on the A320. The Elec page has been called manually using the dedicated Elec key on the ECP. If you compare the A320 AC section to the A330 Elec AC page, you can see that the architecture is very similar except for a single external power source on the A320. Now let's compare the A320 DC section to the A330 Elec DC. There are three major differences to note between the two aircraft. The APU is started on DC essential bus instead of APU BAT on the A330. The DC essential bus is normally supplied by TR1 instead of essential TR on the A330. The static inverter is not displayed on the A320 Elec page. Here is the A330 overhead panel that you already know, and shown below, the new A320 panel layout. Let's highlight the differences. Two engine-driven generator push-button switches are also installed with the associated guarded IDG push-button switches. But on the A320, there is no IDG off indication. On the A320, there is only one external power push-button switch. Note, on the A320, the external power has priority over the APU generator, and the engine generators have priority over the external power. The AC Essential Feed push-button switch, which is used for AC Essential Bus power from Gen 2 or AC Bus 2, is not guarded on the A320. On the A320, there is also a galley push-button switch. But the commercial push-button switch is an option on the A320 instead of standard equipment on the A330. Like the A330, there are two push-button switches for the two main batteries. But the APU battery push-button does not exist on the A320. On the A320, the main battery indications are displayed on for both batteries. Note, on the A320, there is no switch to select the battery voltage indication. On the A320, all the circuit breakers are located in the cockpit, instead of the avionics bay on the A330. Note, there is also no specific CB page on the A320 ECAM. Notice that on the A320 there is no reset panel. Like the A330 for emergency cases, the A320 has an Emer Elec power panel on the left-hand side of the overhead panel. There are some slight differences on this panel. On the A320, there is no land recovery function. A Gen 1 line push-button switch is used when smoke is detected in the avionics ventilation duct. This will be seen in more detail in the abnormal operation module. On the A320, the operation of the guarded RAT and Emer Gen Man-On push-button switch also controls the RAT extension. The emergency generator is powered by the blue hydraulic system instead of the green one on the A330. We will start this module by highlighting the major differences between the two aircraft concerning the emergency electrical configuration. Then we will finish the presentation by showing the failures which are specific to the A320. In flight, in the case of emergency electrical configuration, once the Emer Gen is online, the power supply to the captain's ND is restored on both aircraft. Note, the captain's ND would not have been restored on the A330 if the emergency generator was supplied by the RAT instead of the engine-driven hydraulic pump. Notice that on the A320, the Man-On guarded push button also controls the RAT extension, instead of only the emergency generator on the A330. Note, if the emergency generator does not run automatically, you will have to manually switch it on by using the Man-On guarded push button. There is another difference between the two aircraft. On the A320, in the emergency electrical configuration, the RAT automatically deploys, but not on the A330. Note, if the RAT is required on the A320, the emergency generator is cut off at landing gear extension, leading the aircraft to be powered by batteries only. Observe that you have to maintain a minimum speed when the RAT is extended. Caution: below this minimum speed, the RAT will stall and the aircraft will be supplied by the batteries only. The Elec page has been called for you by pressing and holding its associated key on the ECP. Notice that the Emer Gen supplies the AC Essential bus and the DC Essential bus via the Essential TR. As soon as the ECP push-button switch is released, the engine warning display is displayed on the upper display. If we take a look at the procedure itself, it is very similar for both aircraft. You will have to reset the generators. If not successful, you will isolate the two sides using the bus tie push-button switch and reset the generators again. As you can see on the engine warning display, only VHF1, HF1 and ATC1 are supplied. All the ECAM actions have been completed. As soon as the last one is cleared, memo messages appear on the engine warning display. The green RAT out memo message confirms that the RAT is extended. The green Emer Gen memo message indicates that the emergency generator is running and supplying the system. At low speed during the approach phase, when the landing gear is down, the emergency generator is no longer powered and the supply is automatically transferred to the batteries. On the ground, when the speed is below 100 knots, the DC BAT bus is automatically connected to the batteries. At low speed, below 50 knots, the AC Essential bus is shed, leading to the loss of all display units. In the case of AC Bus 1 failure, the automatic AC Essential feed switching doesn't exist on the A320. You have to press the AC Essential feed push button on the overhead panel to supply the AC Essential bus from AC Bus 2 and then recover the DC Essential bus feeding through the Essential TR. We will now review a failure that we did not have the opportunity to see when performing the previous procedures. In case of smoke detection in the avionics bay, the amber smoke light on the Gen 1 line push-button switch comes on. A master caution and an ECAM procedure are also triggered. When the Gen 1 line push-button switch is pressed off, Generator 1 is disconnected from the system, and the avionics smoke ECAM procedure leads to the shedding of the main bus bars. In this case, the electrical distribution is the same as in the emergency configuration, except for the fuel pumps which remain supplied. This will be seen in more detail during the simulator sessions.